Welcome class. This is our ninth lecture. In last lecture we discussed about the fossil fuels and future renewable sources. Today our topic is about what is soil, different types of soil, and what is salinity. Okay, if we move forward, let's start with the what is soil. Well, soil is a mixture of minerals, organic matters, gases, liquids, and countless organisms that together support life on Earth. Soil is a natural body called the phytosphere, which has four important functions. First one is it is a medium for plant growth. Second, it is means of water storage, supply, and purification. Uh, and third, it is a modifier of Earth's atmosphere. And fourth one, it is a habitat of organisms, all of which in turn modify the soil. Soil is called the skin of the earth and interfaces with the lithosphere, the hydrosphere, the atmosphere, and the biosphere. The term literally used commonly to refer to the soil, literally translate ground stone. Soil consists of a solid phase of minerals uh, and organic matter as well as porous phase that holds gases and water. Accordingly, soil are often treated as a three-state system, including like solids, liquids, and gases. Soil is a product of the influence of climate, relief, relief including elevation, orientation, and slope of wind, organisms and its parent materials interacting over time. Soil continually undergoes development by way of numerous physical, chemical, and biological processes, which include weathering with associated erosion. Given its complexity and strong internal connectedness, soil has been considered as an ecosystem by soil ecologists. If we move forward next, like is soil science. Soil science has two basic branch of study. Two basic branch of study: edapology and pedology. Edapology is concerned with the influence of soil on living things. Like it includes the study of how soil influences humankind's use of land for plant growth as well as people's overall use of the land. On the other hand, pedology is focused on the formation, description, and classification of soil in the natural environment. In engineering terms, soil is referred to as regular or loose rock material that lies above the solid geology. Soil is commonly referred to as earth or dirt. Technically, the term dirt should be restricted to displaced soil. Okay, if we move forward, next is about types of soils. One of the most important things to learn about to ensure successful crops and plants in your soil type, because each soil type has its own method to improve the soil in order to get the best from your plants, because in every condition you have to face different situations, so you need to understand different kind of types so you can deal accordingly. Some plants may struggle to grow and survive in certain types of soil. The best way to ensure good growth is incorporating plenty of organic matter every year. Okay, let's see. First one is sandy soils. Sandy soils are free draining with the largest but fine and hard particles. It has gritty feel. It does not bind very well. It is poor in holding water and easily warm up in the spring season. Sandy soils are very low in nutrients as they are usually washed away. Its degree of aeration depends on the sizes of the particles, particles which vary a lot in size. In second, silty soil. This kind is finer, smoother in texture and hold water better than sandy soils. It also hold up nutrients and make it better for crop cultivation. Silty soil are heavier than sandy soils and almost midway between the properties of sandy and clay soil. The third one is clay soil. Clay is basically the particles that make up clay are the finest and they bind very well. It has very little airspace. Clay very sticky when wet and can be molded into any shape and form. But when they dry, they are rock hard. Clay soils do not drain very well. Clay is believed to form in places where rock is in contact with water, air, or stream. Like example is sediments on the sea or lake bottoms may become clay soil with the time. Fourth one is about loamy soils. This soil is a mixture of sand, clay, and silt particles, and it has the ability to retain water. It is high in calcium, aeration, and ideal for most crops and vegetables. It is the soil all farmers dream of as it is full of nutrients from decomposed organic material. It is soft and easy to cultivate. Next is peaty soils. Peaty soil is acidic and as a result does not support decomposition very well. It is dark in color, rich in organic materials, although contains less nutrients than loamy soils. It retains water very well. Last one is chalky soils. Uh, Chalky soils are alkaline with the pH potential of a region of about 7.5. It is not acidic and often stony with chalk or limestone bedrock. It is free draining because of its coarse and stony nature. Not the best for crops to grow in as they lack uh, manganese and the iron. Okay, if we see after treating these types, we can say that loamy soil is best type for because it has ability to retain water. It is high in calcium. Well, definitely it is all former dream, and it is soft and easy to cultivate. So this overall this type in which loamy is the best types for compare with other types. Okay, if we move forward, it is already done. Soil salinity. Soil salinity is the salt content in the soil. The process of increasing the salt content is known as salinization. Salts occur naturally within soils and water. Salination can be caused by natural processes such as minerals gathering or by the gradual withdrawal of an ocean. It also come about through artificial process such as irrigation. Like over 2.5 million hectares of irrigated land is affected with several surface salinity, with 18% affecting lands in Sindh, 3% in the Punjab, and 2% in NWFP. The moderately affected areas are 10% in Sindh, 4% in the Punjab, and around 2% in NWFP. Modern research has identified more than 1500 plant species that have high level of tolerance to saline soils. These are called halophytes. Some of these are able to withstand salt concentration in excess of those found in seawater. Like these plants are a major resource that can be used in the development of agriculture system for salt affected soils. In addition, there are opportunity to increase the salt tolerance of existing crops using conventional plant breeding and molecular biological approach. This research conducted over the last decade shows that there is a wide range of plant species with varying levels of salt tolerance that can be used in saline agriculture. Furthermore, at least some of these plants are able to lower local water tables, improving the condition of the land and acting as a biological pumps. Saline agriculture can be profitable and practical when you under proper management and by observing suitable precautionary measures. Initial establishment is critical for subsequent plant growth and hence stress should be minimized as far as possible at this stage. Saline agriculture is an economical and practical approach to use unproductive lands for growing various plants and food crops. That was about soil salinity and how it can be effectable, it can be profitable, or it can be related to environmental science. Next is about dry land salinity. Dry land salinity. Salinity in dry land can occur when the water table is between 2 or 3 meters from the surface of the soil. The salts from the groundwater are raised by capillary action to the surface of the soil. This occurs when groundwater is saline and it's favored by land use practices, allowing more rainwater to enter the aquifer than it could accommodate. Like for example, the clearing of trees for agriculture is a major reason for dry land salinity in some areas, since deep rooting of trees has been replaced by shallow rooting of annual crops. Salinity due to irrigation. Like what are the reason? Like some like rain or irrigation in the absence of bleaching can bring salts to the surface by capillary action. Salinity from irrigation can occur over time whenever irrigation occurs, since almost all water contains some dissolved salt. When the plants use water, the salts are left behind in the soil and eventually begin to accumulate. like since soil salinity make it more difficult for plants to absorb soil moisture, these soil must be leached out of the plant root zone by applying additional water. This water in excess of plant need is called leaching fraction. Salination from irrigation water is also greatly increased by poor drainage and use of saline water for irrigation agriculture crops. Salinity is in urban areas often results from the combination of irrigation and groundwater processes. Irrigation is also now common in cities like gardens and restrictions areas. We move forward. Next is uh, consequences of salinity. The consequences of salinity are like detrimental effect on plant growth and yield, damage to infrastructure like roads, bridges, operations of pipes and cables, reductions of water quality for users, sedimentations problems, soil erosion ultimately when crops are too strong affected by the amounts of salt. Salinity is an important land degradation problem. Soil salinity can be reduced by leaching soluble salts out of soil with excess irrigation water. Soil salinity controls involve water table controls and flushing in the combination with tile drainage or another form of subsurface drainage. Sensitivity crops lose their vigor already in slightly saline soils. Most crops are negatively affected by saline soils, and only salinity resistant crops thrive in severely saline soils. Even high level of soil salinity can be tolerated if salt-tolerant plants are grown. Soil salinity can be reversed, but it takes time and it's expensive. Solutions include like improving inefficiency of irrigation, channel capturing and treating salty drainage water, setting up desalting plants, and increasing the amount of water that gets into aquifers. Mulch to save water can also be applied to crops. I guess that's it, class, for today's lecture. Uh, Still, you have any inquiries, you can ask in me in discussion room, or either you can send me a mail. Let's recall the today lectures. Today our topic is about soil. We discuss about soil. There took these two branches. After that, we discuss about soil types, which sandy soils, silty soils, clay, loamy soils, peaty soils, chalky soils. After that, we discuss soil salinity, dryland salinity, salinity due to irrigations, and consequences of salinity, and some kind of treatment about the salinity. You can use multiple resources to learn this topic. You can use you can read through multiple books, nets, even through your own sources. The basic purpose you really need to understand these topics. You can ask me if you have any question, because that is about, and class keep focus on their assignments and final term paper. Uh, anyway, Stay safe, stay home. See you in next lecture with next topic. Love sisters.